All right, here we go. What I like to do is I like to sort of label all the forces acting on this, right? So we've got this F1, it's acting there. I'm going to guess incorrectly that that's an upward force. Okay, and then we've got F2 is acting here. I know that's going to be bigger because there's more weight closer to this one, right? Okay. Then we've got the weight of the beam, right? So the beam is acting down, and since the beam is 8.2 meters long, I believe from the left side, right, this guy is, we've got 18 times G, where G is just going to be 9.81, okay? So you've got 18G acting down here, right? And since the beam is 8.20 meters long, this is at 4.1 meters, okay? F2 is at, let's see, 3 meters from the left side, right? So what I haven't explained here is that we're going to torque about the left side, kind of like we always do. Always torque where there is an unknown force acting, and then you can drop that out of the torque equation. Okay, so let's see. And then you've got the person, right? The force of gravity on them, which is 63G. And then where is that? Let's see, they are half a meter from the right side. So if the right side is 8.2 from the left, then this person is 7.7. Okay? Now, the other thing you got to do with torque is we got to know where the force is exerted, but we also need to decide whether it's clockwise or anti-clockwise. I think this is going to make an anti-clockwise torque, so I'm going to make this negative. Okay, because it's anti-clockwise. This is going to be a clockwise torque. It's going to tend to, about this point, make this thing pivot clockwise, in the way of the clock, right? So this is going to be positive or clockwise, right? And this also will be clockwise. About that point, this force would be clockwise. Okay, let's see. So now let's set up our y expression, because that's the simplest one. It won't be solvable, though, right? So we've got F1 plus F2 minus, 18G, whoops, minus 63G is 0, right? Now we have two unknowns, one equation, can't solve that, right? So let's set up our torque. Maybe our torque will work, right? Okay, so remember torque is R times F. So this guy is at 0 meters, right? So we have 0 times F1 minus 3 times F2 plus 4.1 times 18G. And by 18G, I mean 18 times 9.81, right? Okay, plus 7.7 times 63G. And then that all adds up to 0, okay? So again, with these torque expressions, things that are anti-clockwise are, this thing tends to spin it to the left, right? The weights tend to spin it to the right, okay? So this thing is solvable for F2. We can do maths here. Okay, are we ready for this? So basically I'm just going to bust this out, divide by 3. Okay, let's try it. 4.1 times 18 times 9.81 plus 7.7 times 63 times 9.81. It's a big number, divide by 3. 1827.603. Okay, so F2 all right, and now we just plug that bad boy into here, right? So we go F1 plus 1827.603 minus 18G minus 63G is 0. Okay, we ready for this? I think we do this and then subtract that to get this. Okay, so 18 times 9.81 plus 63 times 9.81 gives me a big answer. Not so big though. Okay, and then I'm going to subtract the answer I just got. Oops. 794.61. minus 1827.603. I get negative 1032.993. So F1 okay. Isn't that crazy, right? So this one's really, really big, and this one's a little bit smaller, but it's downward, right? Okay, so we would say this is down, this is up. All right, I hope that helps.